all these connections to deal with out in the field. You'll just have a couple of valves and a gauge. So to take the readings, right now, the valve to the discharge of the pump is open, and our discharge pressure is running right about 52 or 53 psi. So I'm going to close the discharge valve, and I'm going to open the suction valve, let the pressure stabilize, and now I'm down to about 9 or 10 psi. So I can take those two pressures, and we'll do that after the video, look at the pump curve and see where the pump's running. So 9 psi, 52, 53 psi, and about 1735 RPM. So what I'm about to do is close this valve on the pump discharge. And when I close this valve, I'm going to throttle the flow. And when I reduce the flow, I'm going to reduce the power the pump has to produce or take out of the system. So you'll know I'm doing that because you're going to hear flow sounds change in this pipe. You're going to hear the speed of the motor, the pitch of the motor change. So it'll be obvious I'm doing something. But before I do that, there's two important things. When you're going to go throttle a pump, well, three really, before you mess with anybody's system, you talk to the operator and make sure they're okay with it. And I've cleared that with everybody here at the Energy Center. Second thing you need to do is think about, what's this pump serve? Well, this pump serves a chiller. If I eliminate flow and the chiller was actually online, I'd trip it out on a safety. That wouldn't be popular with operators in a big plant. I've done that accidentally. And these really big guys with pipe wrenches come and give you a stern talking to. So you don't want to do that. The other thing I want to make sure of is I mark where the valve was so I can put it back. This one's wide open, but that's not always the case. And a lot of times the discharge valve is throttled, and that's controlling the energy consumption in the system. So this valve is wide open and it's marked, so we're good there. I've verified that I'm not going to cause a problem with the chiller. And so I'm going to go ahead and I'm going to start throttling this valve. I'm just using a pair of channel locks to grab it because it doesn't have a very big handle. And so here I go. I'm starting to throttle. And you can probably start to hear the sounds change. The tach's gone up to 1760, 1765. You can hear the pitch of the motor change. And now I'm closed. And now the tach is at 1772 RPM, almost synchronous speed. It was at 1730, 1740 RPM when we started. Let's take a reading to see where the pump operating point is when we look at the pump curve. Our suction pressure is up around, I'm going to say 25, 26 psi. And now I'm going to close the valve to the suction. I'm going to open the valve to the discharge. The discharge pressure is up around 72, 73 psi. So that's the 0 GPM line, and that's how we can determine the impeller size out in the field. We do a shut-off test. So we're back up to 1773 RPM.